Okay, as we all know, sine of x over 2 is just equal to plus or minus the square root of 1/2 times 1 minus cosine x. And this right here is the half angle identity for sine. But have you ever thought about what if we have sine of x over 3? I don't think we have seen a formula to this before, right? But don't worry, let me show you. What we need first is sine of 3 theta, and we need an expression for this in terms of sine theta, so that we can plug in x over 3 into all the thetas, and in fact we'll end up with a cubic equation. Let's continue. First, we break down the 3 theta as theta plus 2 theta. Because this way, we can use the angle sum formula for sine, which says we will just get sine of the first times cosine of the second, and we add sine of the second times cosine of the first. But everything should be in terms of sine theta though, so that means we should fix this and that. And this is the double angle for cosine, and there are 3 versions that we can use, right? We just want to use the one that has only sine theta. So we'll write this as 1 minus 2 sine square theta. And in fact, if you use this identity, you can actually prove this right here, but I'm going to leave that to you. And of course, let's write down the sine theta right here. And for the sine of 2 theta, I'm just going to write that as 2 sine theta cosine theta, and here we have one more. Okay, so this looks good, but here we have cosine theta times cosine theta, which is cosine squared, and in fact we can write this as 1 minus sine squared theta. Here's a little reminder. This right here has a little 2, because that was a double angle identity for cosine. This right here doesn't have the 2. This right here is the Pythagorean identity. Cosine squared theta equals 1 minus sine squared theta. Alright, now we can just go ahead and distribute and combine everything, right? So this right here is sine theta, and then minus 2 sine to the third power theta, and take 2 sine theta times this. So plus 2 sine theta. This times that, minus 2 sine to the third power theta, and this and that gives us negative 4 sine to the third power theta, and this and that gives us plus 3 sine theta. Excellent. Now we look at this and that, and what we'll do is we are going to let theta equals x over 3. Because if we put this right here, 3 and 3 cancel. On the left hand side, we are just going to get sine of x. And then put this right here, we are going to have this equals negative 4 sine to the third power, and then we have x over 3, and then plus 3 sine of x over 3. So now as you can see, this right here is an equation involving sine of x over 3. But this right here is, of course, sine of x over 3 to the third power. But it's okay, because we have gone over the cubic formula, and this is just the depressed version, so it's not so bad. But let's clean things up a little bit. I'm going to move both of these terms to the other side, and we'll see that this right here gives us positive 4. And I will just write this right here as sine of x over 3, and then to the third power. Put this to the other side, that's minus 3, and then I will write that as sine of x over 3, and that is plus sine x, and that's equal to 0. And let's just divide everybody by 4, so we get sine of x over 3 to the third power minus 3 over 4, and then sine of x over 3, and then plus 1 over 4 sine of x, and that's equal to 0. Now, I will have to remind you guys the depressed cubic formula. So, recall. Let me use y. So, when we have y to the third power plus p times y to the first power plus q, if this right here is equal to 0, then we know that y is going to be the cube root of minus q over 2 plus the square root of q squared over 4 plus p to the third power over 27. So as long as you remember this part, you are good to go, because the other part is just the conjugate, right? So just change that to a negative. So that will be plus, and here we have the cube root, and then we have the negative q over 2 minus square root q squared over 4 plus p to the third power over 27. Now we just have to be careful on what the p and q are. P is negative 3 over 4. But in our case right here, q is this thing, because we are going to write sine of x over 3 in terms of sine x, right? So, ladies and gentlemen, have a look. By using this formula, we know that sine of sine of x over 3 equals, let's open this right here, a big cube root. Let me put this down as negative 1 over 2 first. And then we multiply by q, which is this. So we multiply by 1 over 4 sine x. And then we add a square root. And let me write this as 1 over 4 q squared, which is 1 over 4 sine x and then squared. And then we add, that's put down as 1 over 27. And the p is this, negative 3 over 4. And then we raise that to the third power. And of course, the other part is just pretty much the same thing, except you've changed this to a minus. So we are going to add, here we have another big cube root, and then the negative 1/2, parentheses, 1 over 4 sine x, and then minus big square root, 1 over 4 times 1 over 4 sine x square plus 1 over 27 times negative 3 over 4 to the third power. And there you have it. This is the formula for sine of x over 3. But of course, this right here simplifies to a very pretty expression. I'll continue that for you guys. So how are you guys doing? Let me know. Now, I'm not going to write down the two square root, like the cube roots and all that, like twice. I'm just going to focus on one of them, and later we'll put it together, okay? So let's make an observation for this part right here. So this is just a quick observation. So if you look at the cube root, and you see that this times that is just negative 1 over 8. So that's nice. So we get negative 1 over 8, and then we have sine x. And then we have the plus and minus, so I'll just put on plus minus like this. And then we have the big square root here. 1 over 4 squared is 1 over 16 times 1 over 4. So that's 1 over 64. And then we have sine squared x. Then negative 3 to the third power happens to be negative 27. And it happens to be able to cancel with this. And that becomes a minus though. So it's minus. And then we just have to do 4 to the third power, which is 64 on the bottom right here as well. As you can see, we can factor out a 1 over 64 right here. And that will just give us 1 over 8. But in fact, both of them will have the 1 over 8, right? So we can factor that out all the way to the front of the cube root. All in all, we get the 1/2. Then we focus on the cube root. Here we have negative sine x. That's all. All right. And then we took care of the 1 over 64 already. But in fact, this right here becomes what? Sine squared minus 1. Right? This right here, after we factor out the cube root, is just sine squared minus 1. And that's really negative cosine squared x. And that's inside of the cube root. So it's inside of the square root. That gives us negative cosine squared x. What happens? Well, here we have the square root and a negative. We can use the imaginary unit I. So this right here is equal to 1/2, and we have the cube root of, and then we have the negative sine x plus or minus I. And then here we have the cosine square in the square root. Of course, that can be just written as cosine x. So if you look at the cube root part, it actually simplifies to this. And of course, you just now put them together. And now you have the formula for the sine of x over 3. And now let me just erase all that. And the beauty of this is that you can now do whatever you want, like in terms of plugging any x values, but you have to be extremely careful. Anyway though, sine of x over 3, I'm going to write down the first part, and perhaps I'll just factor out the 1/2 all the way to the front. We have the cube root of negative sine x, and then plus I cosine x. Pretty good, huh? And then we are going to combine it with another cube root, and then we have negative sine x, and then minus I cosine x. Oops, I shouldn't put I in red. I cosine x. So just like that. All right, good. Now, what do we want to do with this? Well, remember last time when I was doing the cube root formula, the cubic formula for you guys, I told you guys I will compute sine of 10 degrees for you guys. This is the time. So how can we get sine of 10 degrees? Well, 30 degrees divided by 3 gives us 10 degrees. And we can happen to figure out sine of 30 degrees and cosine of 30 degrees pretty easily, right? So let's go ahead and do that. We are going to let x equals 30 degrees. So that right here, we get sine of 10 degrees. And that's going to be, we have 1/2 and then the cube root. And here's the thing. Let me just write this down for you guys real quick. Remember, sine of 30 degrees, you can refer to your triangle. This is 1/2. And then cosine of 30 degrees, that's equal to square root of 3 over 2. What triangle am I talking about, right? This triangle right here, the special red triangle. That's 1, 2, square root of 3, that. All right, anyway, I'm just gonna put this right here. So we get negative 1/2, and then plus I, and then cosine of x, 30 degrees, that's square root of 3 over 2. And then we combine it with the cube root of negative 1/2 minus I, and then cube root of 3 over 2. Yes. No. Why? First, is this a real number? Well, I see the I here and I here. Sine of 10 degrees has to be real. So the first thing is that we have to make sure that this is indeed real, right? And I tried so many times, I really don't know how to just work it out algebraically. So if you really know how to just write this in terms of just very nice radical expressions without the I, please comment down below and let me know. I don't know how to do it. So what I did was I used a calculator called the Wolfram Alpha. It's really powerful, it's free, it's online. You guys should try it too if you guys don't know about that. And enter everything on the calculator, Wolfram Alpha, you get approximately 0.766. Hey, it's real. But in fact, this right here, it's not sine of 10 degrees. This right here is not sine of 10 degrees. In fact, this right here is equal to sine of, and you have a couple options. This right here, we get sine of 50 degrees. So why? What are we talking about? Why is that I plug in 30 degrees? So I worked out all these numbers, and then 30 degrees divided by 3 gives me 10 degrees. But all of a sudden, this value is actually sine of 50 degrees. So I should cross this out. It's not sine of 10 degrees. Well, the reason is, firstly, if you put 150 into the x right here, you will still end up with the same result. So let me just put a note right here for you guys. Yeah, because sine of 150 degrees, it's also equal to 1/2. Likewise, cosine of 150 degrees, well, we don't care about cosine of 150 degrees. Oh, we should care, huh? yeah, we should care, but like you get plus or minus, so it's alternating. So this is negative square root of 3 over 2. I just realized that. But one's positive, the other one's negative. This is negative square root of 3 over 2, so still doesn't really matter. Here, the main thing is that sine of 30 degrees give you 1/2. Yeah. Likewise, sine of 150 degrees also gives you this situation. So if you plug in 150, divide into 3, you get sine of 50 degrees, and you'll still end up with the same radical expression. So how exactly do we get a sine of 10 degrees though? Well, here's the deal. Remember earlier when I gave you guys the formula, in fact, that's just like the simple version. We also had to talk about the cube root of the 1. Like the cube root of unity. So what we are going to do is, in fact, we also need to check the following. So nothing wrong with this expression, but this is just like the first answer from that cubic equation. What we are going to do is 1/2, and then right here, I'm just going to multiply by the cube root of unity. So remember omega 3 is equal to 1, and that tells you omega is equal to 1. That's it. This is omega 0, and then omega 1 is equal to negative 1/2 plus I square root of 3 over 2. I know it happens to be the same. And then omega 2 is equal to negative 1/2 minus I square root of 3 over 2. And 1 over omega 1 is equal to omega 2. What we'll do is we multiply this by omega 1 first. So I'm going to put this down right here, negative 1/2 plus I square root of 3 over 2. And then multiply by the cube root version right here. So this is negative 1/2 plus I square root of 3 over 2. And then right here, we are going to add, we multiply omega 2 right here. So that's negative 1/2 minus I square root of 3 over 2. And then we multiply by this cube root. So that's what we have right now. And again, this gets even worse, right? And I will tell you, if you use Wolfram alpha, this right here gives you a negative number. This is about negative 0.9397. Again, this is not going to give a sine of 10 degrees because that's for sure positive. And yeah, by the way, why is this though? Well, in fact, this right here is meant to be equal to negative, and then we have sine of 70 degrees. And you might be wondering why 70 degrees. In fact, I went over this in my previous video many years ago. You guys can refer that, but better yet, you guys can think about it. That's much more interesting. Anyway, this right here is still not going to work. So finally, I'm going to just do the other one. So I'll perhaps put this down in blue. So this is like the first answer, second answer. Now I'm going to check the third answer, which is 1/2, and we multiply by, you multiply omega 2 with the first part. So we get negative 1/2 minus I square root of 3 over 2. Don't worry, I remember my parentheses, times the cube root. And then we have the negative 1/2 plus I square root of 3 over 2. And then we add omega 1, which is negative 1/2 plus I square root of 3 over 2, and times this part. So the cube root of negative 1/2 minus I square root of 3 over 2. Please, this right here better be sine of 10 degrees. In fact, it is. First, I'll tell you, this right here is approximately 0.1736. And indeed, this is equal to sine of 10 degrees. Wow. So ladies and gentlemen, if you want to have sine of 10 degrees, there you have it. This is it. So technically, right here for this formula, I will have to tell you to multiply by omega 1 and omega 2 right here. And then similarly, you also need to do omega 2 here and then omega 1. So that's the reciprocal, so perhaps I'll just write it down. Omega 2 and then omega 1. So you don't just get one formula. You have to look at 3 pieces. Can we tell which one is going to give us sine of 10 degrees right away? I don't know. So if you do know, please let me know. Thank you. That's it.